Welcome, my dear students in Prep 1. Today we'll discuss our geometry lesson. It's about parallelogram. We will talk about the properties of parallelogram and also special cases of the parallelogram. We studied before parallelogram in primary 6. We said that the parallelogram is a quadrilateral in which each two opposite sides are parallel. Here, for example, we have ABCD. We have a parallelogram ABCD. In this case, we said each two opposite sides are parallel. It means here, for example, the side AD is parallel to the side BC, and also the side AB is parallel to the side DC. Okay, so each two opposite sides are parallel. Also, each two opposite sides are equal in length. It means that the length of the side AB is the same length of the side DC, and the length of BC is the same as the length of AD. Okay. So we have here another property that each two opposite angles are equal in measure. It means angle A, for example, here angle A, or the measure of angle A is the same as the measure of angle C, and by the same way, measure of angle B is the same as measure of angle D. So each two opposite angles are equal in measure. Okay. Also, we studied that the summation of each two consecutive angles equals 180 degrees. Okay. The summation of each two consecutive angles is 180 degrees. It means that each two consecutive angles are supplementary because the summation is 180 degrees. So measure of angle A is the same plus measure of angle D. Consecutive angles, for example, here A and D are two consecutive angles, angle A and angle D, also angle B with C, A with B. So the measure of angle A here, measure of angle A plus measure of angle D, 180. Also measure of angle B plus measure of angle C, it will be 180. Okay. Also, the two diagonals bisect each other. The two diagonals in the parallelogram bisect each other. It means that the length of MD is the same as the length of MB, and MC equals MA. So the two diagonals bisect each other. It means they are intersect at the midpoint. But the two diagonals not equal in length, but they bisect each other. It means, for example, if this diagonal is 10, it means here we have 5 and here we have 5, and the other diagonal can be, for example, 12. So here we have 6 and here we have 6. Okay, it's not necessary that the two diagonals are equal in length, but they are bisect each other. If you want to calculate the perimeter of the parallelogram, you will multiply the summation of two consecutive sides by 2. For example, the length of side AD plus DC, then multiply by 2. Okay. We have special cases of the parallelogram. Also, we have studied some special cases last year. We have here, for example, the square. Square is a special case of the parallelogram. In a square, all sides are equal in length. All the sides of a square are equal in length. And we studied before that the perimeter of the square is 4 times the side length, and its area is side length by itself. What about the angles? The angle here in a square, or all angles are right angles. It means 90 degrees, each of them. The diagonals here, the diagonals and the square perpendicular and equal in length and also bisect each other. We said that we have special cases of the parallelogram. It means here all the shapes here, square, rectangle, and rhombus, have the same properties of the parallelogram and much more. Okay, so here we have all the properties of parallelogram is satisfied here in square, in rectangle, in rhombus, and more than or in addition to these properties, we have, for example, here the angles are 90. Also, the diagonals are equal in length, bisect each other, and perpendicular and equal in length. What about the rectangle? In rectangle, each two opposite sides are parallel and equal in length, like a parallelogram. We have length and width here. All angles are right angle, like a square, and the diagonals are equal in length and bisect each other. So the diagonals are equal in length in rectangle. Let's move to the rhombus. The rhombus here, all sides are equal in length, like the square. Each two opposite angles are equal in measure of, but it doesn't equal 90 degrees. The diagonals here, the diagonals are perpendicular and bisect each other, but they shouldn't be equal in length. So the diagonals equal in length in the rectangle. The diagonals are perpendicular in the rhombus, and the diagonals are perpendicular and equal in length at the same time in the square. We have another quadrilateral which is not a parallelogram. This quadrilateral is the trapezium. In trapezium, each two opposite sides are not each two opposite sides, only one or only two opposite sides are parallel. So this side is parallel to this side. Only two sides are parallel. The other two sides are not parallel. Okay. So the trapezium is not a parallelogram. So we studied the properties of parallelogram and special cases of parallelogram. Now I want you to know how to prove that a quadrilateral is a parallelogram. If you have a quadrilateral and you want to prove that the quadrilateral is a parallelogram, you should prove only one of the following. The first one, you can prove that each two opposite sides are parallel, and this is enough to be a parallelogram, or each two opposite sides are equal in length, and also this property is enough to be a parallelogram, or that not each two opposite sides. If you can prove that two opposite sides are parallel and at the same time equal in length, so also that's enough to prove that this is a parallelogram. Each two opposite angles are equal in measure. If you can prove that each two opposite angles are equal in measure, then also it's enough to be a parallelogram. Or the two diagonals bisect each other. Also, this property is enough to be a parallelogram. Okay, that's all about our session today. We studied today the properties of a parallelogram and some special cases of parallelogram, the properties of a square, rhombus, and rectangle. We said that trapezium is not a parallelogram. At trapezium, only two opposite sides are parallel. Next session, we will start another session or another lesson in geometry, which is the triangle. Thank you very much for watching. See you next session. Goodbye.